So I'm happy to be here and to talk to you about Scala.js. So first I would like to introduce myself. My name is Maciek Pro, and once upon a time I was an algebraic topologist. I dealt with homology, homotopical limits, and various different stuff. But you know, you have to earn the living. So then I'm working for more than 7 years at a small software house called TOG. We're based in Warsaw, Poland, and I'm mostly involved in doing many kind of integration stuff, dealt with Camel, OSGI. I also like to code in Scala, pursue some different architectures like CQRS, and so on and so on. So you may wonder, what's a guy like me doing in this web and mobile track? Maybe that's why nobody came, because everybody knew who am I. But a few years ago, I was almost full stack developer, right? So I knew how to do some CSS, some JavaScript and stuff. But now, and we were happy because we want to be a Renaissance developer, we want to have cross-functional teams and so on and so on. But now if you want to do full stack development, you have to learn CoffeeScript, Angular, Grunt, Jade, Less, Gulp, React, Bower, NPM, Node.js, and the new ones, Falcor and Relay. With each time I do this talk, I have to add another features. Yeah. These are just small amount of examples. I know they are far many. So, yeah, not to mention everything concerning Angular. So, you know, in some of our projects, we are reaching a stage when we have kind of silos, when you have back-end development and front-end development, and they cannot talk to each other because they have different build script, different repositories, and so on. And that's not good for cross-functional teams. So what do you want to do when you have such situations? Well, one way is to have isomorphic JavaScript, so JavaScript on the server side. But if you look at this well-known photo, this is, if you don't know, this is DAX Croc for JavaScript good parts, and this is JavaScript complete reference guide, right? So, you know, if somebody's doing full JavaScript, maybe it will be okay if he learns or she learns it by heart. And now there's ECMA 6 or whatever with classes, arrow notation, so on, so on. But when you do mostly backend systems, and from time to time you to delve into frontend, then what you want to do? You want to stay on JVM, and that's why GWT was invented, right? How many of you is old enough to remember GWT? And in fact, you can do great things. This is a web game by my friend who wrote it entirely in GWT. This is one of the screens. But GWT has its problems, right? These are output from our compilation. It takes ages, and you know, development in GWT is not much fun. And I think it's almost dead. Maybe not completely dead, but GWT is, I would say, almost dead. So, do we have no choice? In fact, we have, because there's Scala.js, and more than 1 year ago, it reached version 0.6, and the creators claimed it's no longer experimental. So that's why I'm here, to show you a bit how does it look like and what we can do with it. So the first thing we want to do is, of course, some kind of hello world. So here I have, by the way, how many of you use Scala? Or know a bit? No, don't worry. If not that, pretend it's kind of strange Java. We'll see. So here I'm running my normal Scala build tool. This is my normal class, and we'll do first thing like hello world. And what happens? Now, I wanted to show you that there's good build pipeline, which is waiting for compilations, just like in normal JavaScript development. And when I'll go here, nothing's here. But here, hello world. It's working. So we can end, right? We print it to the JavaScript console, hello world. But what else can we do with it? Well, probably we want to display something not only on JavaScript developer tools, but also on the front end, on HTML. So what do we do? Well, in fact, if we put enough imports on the top of my file, I can use normal DOM API, right? Document, get element by ID, content, and I can do, normal DOM thing, append child, and so on and so on. But I won't do this because it's clumsy, right? We can do something a little bit better. Like we can do container, and we have enough imports. We have small libraries that allow us, in Scala.js, we have small libraries that allow us to build DOM just like that. This is just a simple example. We'll see something better, but let's start with something simple. So I'll make a div, and inside it will be hello world. And this is, what is it? In fact, this is type tag. This is some DSL, our custom-made DSL object. But we can turn it into proper DOM element by choosing render on that. And what's happening? It's compiling. Remember, it's Scala. It doesn't compile fast, just as fast as JavaScript. But hopefully, it even reloads it automatically, right? So there we are. We're almost ready. We can build DOM. But we can also use features that are typical for Scala, like, for example, functions. I've got a function. Click. Okay. We don't have too much time, so we'll end up. So we'll just print I'm here. So what do we need to do this click? Probably we'll need something called button. And it's here, right? We'll say click me. Where am I? Click me. No. Click me, and on click there's a method, and okay, I have to move this upward, and if I tell my DSL that I want it to invoke this function, we'll see, will it work? It's compiling, and it says success. So let's see, it's there. And if I click, it says I'm here. Great, right? So all the basic blocks are here. There are even, what's nice thing is that we can even see the source code in developer tools. Like, let's introduce some errors like this. Guess what will happen? Divide 1 by 0. Compile. You know this, what is this? This is 0. It's the result of division 1 by 0. This is JavaScript, remember. We're not in Scala land anymore. But here, we have an error, right? Because I don't have the element that's content A. And I can jump to the source code. Actually, it's not working too good because there are some crazy developer tools caching issues. But source maps are generated, so we can debug in the browser our Scala code. Just like, for example, you can debug CoffeeScript or TypeScript or whatever script you want in the browser, and not resulting JavaScript. Here you can debug the Scala.js. So what I wanted to show you in this quick example is that we can write Scala code and compile it to JavaScript, just like more or less like using TypeScript, right? The whole tool chain is in place. Everything is ready. We can just code. Where are my slides? Okay, but what's happening when we put this magic annotation JS export on our Scala methods? Well, of course, JavaScript is generated. This is our hello world example, and here is the hello world, right? So this JavaScript doesn't look too nice. So how did we get here? Well, essentially, the Scala compiler is also working when we compile Scala to JavaScript. But normal Scala compilation stops at this point, and then some compiler plugin turns in, and it's not. And when it takes syntax tree, it doesn't create bytecode, but instead it creates some intermediate JavaScript representation. This is this big JavaScript file. And what happens next? Well, essentially, all the other JavaScript files from the libraries that we use are attached, and one gigantic JavaScript file is created. For example, if you know Scala standard library is waiting like 11 megabytes of bytecode, so it's also put into this gigantic JavaScript file. And what happens next? Well, essentially, Google Closure Compiler takes its place, and it optimizes all the stuff to nice little JavaScript file. Okay, it's not so small, but it's like, I think like 100 kilobytes or so for this Hello World example, so it's not that bad. And it also generates these crazy source map files that enable us to debug this stuff in browser. So again, this is, it may look weird if you are not a front-end developer, but if you are, you recognize this is a common pattern in today's web development. Right, so in fact it's even more funny because when you see here, we have to have this intermediate JavaScript representation of all the libraries that we use, including normal Java libraries from the standard library. So creators of Scala.js had to re-implement most of the standard libraries that they wanted to use. For example, this is byte array input stream written in Scala, right? So probably it's not so performant, not so good as in JDK, but this effort has been made because, well, it needed to be made. And we can also use many of the standard Scala libraries without any problem, like Scala-Z, Shapeless, Macquarie, probably some Akka, although I guess it won't work for many cases. Sorry. And in fact, it's much easier to use normal Scala libraries in Scala.js than it was the case with GWT. Why? Because the common problem with compiling Java or Scala to JavaScript is that at some point you have to prune the classes. You cannot have all the standard library with generated JavaScript loaded into your browser each time because it will be too big. So there's these Google Closure compilers and other compilers. What they are doing are essentially pruning the libraries and just they look at the source code and create a graph of reachable classes, right? So if we are not using some class from this or that library, it won't be included in JavaScript, which results in well-known problem in GWT that you cannot use reflection. And for Java, this is a game changer. It's very difficult to do some, normal Java development like dependency injection and stuff without using reflection. And that's why using GWT was a pain. But in Scala, we have macros. And macros are so much better from reflection because they are applied at the abstract syntax tree level during compilation. So all those Scala libraries that rely not on reflection but on macros, they can just work. And they work because they modify the syntax tree and they output just like normal bytecode. So that's why it's possible to use Scala-Z, Shapeless, and other Scala libraries without much change. So this is a big deal, and we'll see in a moment how well we do it. We'll also see. This is the example that I've shown to you a little bit more expanded, but here we'll see how to develop kind of a little bit more complex application. Communicating also with the backend. So if we look at the browser, it's here. So again, it's there's a button we can click and something is appended. So what do we want to do? Now we want to invoke some AJAX functions, right? We cannot have a web application without invoking external services. So we'll see how Scala.js does this and how it employs kind of common Scala patterns. So we'll see search does, or maybe load. We'll make a function load data with a URL, and we'll see where do we end. So it turns out that there's AJAX object. We can invoke get method on that. And what do we get? We'll see. I don't know if you can see this, but this is future of DOM result. And this is normal Scala future. So we can invoke normal methods on that. When the invocation completes, we can extract the text. And yeah, probably we don't want to parse the JSON by itself, and we don't have eval method like in JavaScript. So we'll use another library from small but vibrant Scala.js ecosystem. We'll map. And the library is called upickle, and it basically can encode and decode case classes to JSON and other stuff. And as I said, it's based on macros, so it can extract some type information from, provided that we provide it with some extra meta type level information. It can extract all the necessary fields and stuff like that, and create the object that we want. So let's see how does it look in practice. I want to show you an example with nominatim service. It's geolocalization service. Mainly you put what do you want to query, like CBU, and you are provided with a list of places that match your query. Okay, so I have some prepared URLs because I wouldn't be able to remember all of that. And let's see. Search location. This will be our search string, and we'll make load data. Here I have to remember to interpolate the strings in Scala. And what will be the type? In fact, for this project, I provided a small model class it will be called Geolocation. So it's normal Scala case class. There are some annotations that will be used by upickle to detect what are the fields named and translated to the fields of the case class. But apart from that, we are just telling it that we want it to load a list of geolocations. Right, and what do we get here? Is the future of list of geolocation. More or less like we expected. And then again, we can do normal stuff with the futures. Like for example, we can say, let's take only the first of locations that was returned by nominatim. Right? So as you can see, all of this is normal Scala code. Nothing Scala.js here apart from AJAX get URL. But still, it's gonna work. We'll see how. So when we click, what do? We do search location of add element, get value, and for each, again, this is normal method from the Scala API. Maybe location, maybe there is, maybe something is found, maybe not. Who knows? Maybe location, and we'll take the element value, and we'll print this location to see if it's really working. For now, we'll just use toString because we don't have enough time and energy to do anything better. So again, compiles. Hopefully, yeah, it compiled. And where are we? We are here. This is the former demo, so we can close it. Let's see if let's write. I want to write CBU, but I missed CBU. And yeah, do you recognize its longitude and latitude? It's there, right? So we invoked it, and another basic block is in place, right? We can invoke Ajax, we can manipulate DOM, so we can do basically anything we like, right? In fact, we can do even more. Sorry, that's again wrong demo. We can do even more because we can use more complex libraries from Scala Toolbox, for example, Scala-Z. And to show you that, if you are afraid of monad transformers and the like, don't panic. It will be fast, right? I'll use some Scala library, Scala-Z monad transformers, to load comments for our location service. Imagine we're building a site. When you enter the name, and the locations are loaded, and then some list of comments from our probably NoSQL database are also loaded and displayed. So here, option T, this is everything is just like in our backend Scala code. We have locations that we found, first location that we found, and we load more data. In fact, we are loading a list of comment. There's also some small domain class that will be mapped to our small service returning comments for the location. And where is it? Essentially, it's written in using Akka HTTP, and it's also run by SBT as we develop, right? So again, it's common Scala build tool pattern. And which location are we going to get? This is the location, and there is it probably. Yeah, this is geolocation, so the string is not particularly well interpolated. Yeah, this is string. So we've loaded string. We loaded comments for that locations, and again we use idiomatic Scala or Scala-Z code. And what will we do with it? As with normal idiomatic Scala-Z code, it's not so easily readable, right? But hopefully it will work. So this whole damn function has now option of T of future of geolocation type. And now again, this is the end of our adventure with Scala-Z. But if you know it, you know that that's the way you more or less write such stuff. And if you don't, then now you know how how you can do real functional programming in Scala if you are brave enough. Right, so again, let's see if it's working. Yeah, and here's a list of comments. Somebody said Sibiu in Romania is brilliant, and so on. So basically it's working. Unfortunately, the list of comments is fixed, so I won't try to get some different results, but still. Where is my code? My code is here. But if you look at that, you'll see that, you wouldn't write a bigger application in a way like that, right? There's no structure. It's just, you wouldn't, right? You need some more building blocks in place. Mainly, what do you need? Well, essentially, you need JavaScript frameworks. These are many, many, many of them, and they are scorned the earth. But fortunately, it's year 2016, and we're still alive. There are not so many of them, but we have to choose one. And you know what? It won't be Angular. It will be React, which is fortunately one of the most popular nowadays and trendy ones. But why do we pick this one? No? You disagree? Okay. Okay, so why did I choose React? Because it's well suited for our Scala.js purposes. First thing is that it handles just the view, right? As I've shown you, or tried to show you, we can use more or less idiomatic Scala code to handle logic, communication with external services, and so on. So we don't need some clunky AngularJS two-way data binding stuff, because we can write normal Scala code for that. But handling DOM is not properly covered by Scala.js, because, well, the community is small and it's quite difficult to do proper DOM library, at least in my opinion. So React is good for that. And what's more, it's like React is focused on enabling kind of functional style of programming, right? It's a component framework, and one of the key features of React is focused on composability of the components and immutability of the state that these components use. And also there's nice feature like virtual DOM that allows React to handle many of the internals of DOM manipulations, which are hard to get performance-wise and hard to get to work in all the browsers. So these are the features that will work for us, hopefully. So as I said, React is a component framework. And when we develop a component, it receives some properties, immutable properties. This is important for us from the outside. And it has some internal state. And the state is also immutable, or should be. And based on those data, it can render itself to the virtual DOM that will in turn be rendered by React in the browser. Right, so important thing for us is that this and this is immutable. So it's well fit for our purposes. Right, and if we create a hierarchy of components, they have to communicate each other. The state is private for the component, so there have to be some mechanisms in place that enable communication, and so on. So things start to get more complicated than that. But for our short demo, I hope we will be okay. And of course, we won't use React just like that, because there's Scala.js wrapper for React. It's called Scala.js React. It's written by a guy called, at least his GitHub name is Yabgoli or something like that. And it's quite functional in design. We'll see it in a moment. So how are we going to proceed? First, let's develop some simple component that will display our location that was returned by the search service with the comments. So how are we going to do this? Geolocation component. First, we want to define it. And we use the builder of the React Scala React.js. And first we have to define what are the properties that will be displayed by this component. So it will be option of geolocation. Then we have to tell what's the name of this React component. Geolocation comp, like that. And then we have extensive builder pattern. There are lots of methods. First, we'll tell that it will be stateless component. It will just display data and won't maintain any internal state. And then we have to tell it how to render itself. As you can see, we have many methods that enable us to render. Let's use one of them. And as a parameter, it gets this option of geolocation. So again, we can use kind of idiomatic Scala code. If we don't have geolocation, for example, the search service didn't return anything, then what will we do? We'll display, for example, a div, sorry, no result. As you can see, this is kind of not so nice. We have to use another small library that's enabled us to define the tags. It looks kind of weird, but when you get used to it, it's okay, right? It's just like HTML tag, right? Well, the creator of the library surely knows better than we. And if we have some location, what do we do? Well, probably we want to display the name of the location, and maybe, because why not, we can display the list of comments. And again, as I said so many times in this presentation, we can use just normal Scala collections methods, and we just create some list elements of for example, I don't know, content. Right, and that's almost all. But wait, this is a builder pattern, so what do we have to invoke at the end? Of course, we have to invoke the build method. So now we've created, in fact, we created JavaScript class called Geolocation Comp. So how do we use it? First, we have to, okay, I will move it a little bit up to be able to use it in our current setting. And when our search service returns us a list of locations and comments, what do we do? Well, we invoke some nice static method that's called geo. We are creating a geolocation component. We're passing our searched geolocation to it, and we tell it where should it be rendered. On which DOM node it should be rendered. And if I hadn't messed up with the parentheses, I haven't? Ah, that's great. The first time in a row. So again, it's compiling, and where are we? No, I wanted to. Right, and the list is displayed. So it worked. It's simple stateless component, but what's nice thing about it, about the components, is that can be easily composed, kind of like normal Scala objects. Like I've prepared for this demo another small component that's using OpenLayers library. Do you know it? It's for displaying kind of an alternative to Google Maps. So we've defined a component to display a layer, and when we have location, we have its coordinates, right? Longitude, latitude. So we just say, okay, so here renders div ul, and then render this component. And it will be hopefully really easily composable. Let's wait a sec. Again, here it load it. Again, I'm using Sibu because it's a simple name. And here it is, right? So again, this is an example of using normal JavaScript library that's doing kind of complex stuff. And then essentially what I did, first I wrote some small facade library to expose the OpenLayers API to Scala-JS, and then I've built small React.js component to display the map with this round circle. In fact, this component, where is it? This component is a little bit more elaborate, so probably I won't tell you too much about it because we don't have too much time. But this is the way how do you develop some simple stateless React components. But stateless components are okay, but we need also some stateful components, right? Because currently we just got to keep everything in our DOM. So what do we want? What will we do when we want to put some state in our application? And how do we, in fact, move all the stuff that we have here in this row, I would say DOM API, to React? So we need another component. This will be a little bit more complex. So first, we have to decide what is the state of our application. So the state of our application, the first part, of course you can do it in different way also, but we'll do it in this one. So our state will be the search string and current location. This will be option of geolocation, and now we will define our nice stateful component. And how will we call it? Probably searcher. So again, we use our builder pattern component B. This time it will be self-contained, right? This will be our kind of top component. It won't get any props from outside, so it will its props will be units, right? And again, we'll give it a name like searcher. And this time it won't be stateless. Instead, we have to tell it what's the initial state. So probably it's empty string and no. It will be. Let's do it like this. No search location. Compile, compile, compile. But now, instead of this simple render method, unfortunately we have to develop one more class. Because in Scala, you define usually much more classes than in standard Java. So what will we do? We'll create. But I promise this is the last class of this presentation. We'll develop a class called backend. In fact, if you look at the React.js proper, I mean the JavaScript version, it also does similar things. This is a little bit tricky and more elaborate, but hopefully you'll see what it's all about. So have a class backend, and now inside, you'll see in a minute why we have a separate class. And now we'll make a method called render, and this time it won't render itself based on the properties, but based on state. And it shouldn't. Let's infer it. So, what are we going to render? Well, what will be our component? Of course, it will be a div. And what will be inside this div? Well, of course, there will be our input field. Now, again, this is the feature of this library, that this is how you define attributes. Again, there are some good reasons to do that. And what's the value of this input? Its value, well, essentially it will be our search term, right? And what's next? What do we have to render? Again, we have to render a button. Okay, something like click me. And the last thing is, of course, we use our geolocation component that we defined before. So how it will render? Of course, it will render the current location, right? See? So again, this is normal, well, Scala.js React DSL for defining div, some normal DOM components, and inside also using some custom defined component. So almost everything is in place except one thing, except changing of the state, that is reaction to clicking the button or entering some text, right? We don't have anything like that here. So we have to define, for example, what happens if we change the value of our input. And this is another funky symbol that is so common for all Scala development. And it will be set search. And again, this should be a method. So that's why we defined another class that has access to the state, because now we are able to define the method. Set. We are able to define the method that will handle this action, and it will react even. Oh gosh, somebody's. And what are we going to do? We want to modify the state. Here there's some wrapper for the state that will allow us to modify it. So what are we going to do? We're going to change. Our state is just normal case class. So we just copy the search term from, where is my cursor? From event target and value. Right, again, this part is normal JavaScript DOM API, right? We take DOM event, what component does it come from, and the value. So this is kind of primitive, but it works. What is more interesting is that it's not a unit type of this function, but it's callback. As I said, Scala.js React is pretty focused on functional programming, and again, it embeds creates some monads that enable us to handle features like synchronous updates, dealing with the threads, and so on. But it can look kind of clumsy. We'll see it in a moment. So we can change the state when we enter something, but what should happen on click? We'll invoke method search. Notice that these are double dashed line because we have some parameters, and here is a single line because there will be no parameters. Find it quite funny that somebody thinks about such things, but you know. So what happens when we search? Well, we have to take our current state, right? To take our current search term, but as I said, we won't be just given the state, but a callback to a state as again some kind of reader-writer method or whatever. But fortunately, we can map. We can take current search term, and then what will we do? If we have a monad, we can probably do a flat map. Right, search term, and again, what will we do? Now there will be the search action, right? It basically says that when the user clicks and you reach a stage when you want to perform some action, do this function, and we have search locations given search term. And what should happen when we are back with our search result? Again, this time we will map. We'll take the option of location that we are given, and again we'll modify the state, right? Because another part of our state is is our current location. It's copy and let's look. So that's all great, but unfortunately it doesn't compile because this function wants us to be given a callback, and we have a future of callback. There are some, fortunately, there are some utility functions that enable us to come out of this place. Right, it compiles. Now, yeah, I know. Thanks. So let's see if it's working. It compile. This time it will take longer time because our code is pretty complex, right? Let's see. Again, let's reload it and let's see. Are we there yet? Yeah. Fortunately, it's working. So now, and in fact, this is all of the code that I wanted to show you. So now we'll remove the dead code that were our earlier attempts, right? So no, sorry. That I've shown you was the earlier version because we defined only the component, but in fact we didn't even properly define it, but we didn't use it. So now we've built the component. Now we destroy all our earlier work, and now React DOM render searcher. This will be the only component, the only element of our application. No more crazy DOM manipulation. Right. So this is what's left from the code. Unfortunately, the resolution is not too good, but when you look at it, this is, and think about it, this is, in my opinion, pretty reasonable Scala code. Of course, it should be polished, some error handling and stuff should be also employed, but this is normal Scala code. Also this, the definition of stateless components, in my opinion, this looks pretty reasonable. I can imagine how to build bigger components out of such stuff. What still is not too nice for me is this part. I even didn't dare to explain to you in 2 or 3 minutes what's happening, what's the interplay of these callbacks and futures. But the good thing is that this clunky and bad part is just the beginning that we can take and define kind of next level of, well, libraries and frameworks. Because if you know what's happening in the React world, there are some certain patterns and architecture styles called like Redux, Flux, and stuff like that. And also in Scala.js, there are some certain libraries and frameworks like Diode that enable us to take this clunky piece of code and take it to the next level. Basically, what's not working here is that we mix responsibilities. We handle changing of the state, and we also want to invoke external services and react to our actions and so on. So if we are to use these more complex ways of building applications, we can just in a way have one global state that will be modified centrally by some event-driven kind of framework. But I won't show you this today because it's, well, kind of far too late. But apart from that thing, that not too nice method, in my opinion, this is pretty reasonable way to build application. Of course, there are many other parts like handling CSS, handling errors, and so on and so on. But there are also small libraries for that. So, where is my presentation? So, where are we? In fact, with our journey with Scala.js, we've gone pretty far. We can embrace JS ecosystem, its libraries, but we can also write idiomatic Scala code with Scala libraries and so on. And with the help of JavaScript functional frameworks, we can build our application also in a nice functional composable way. But there are also a few problems. One problem is the speed of the compilation, right? This is the common problem with Scala. So you could see it, right? That it didn't compile in a moment. If you are used to working with JavaScript frameworks, then this compilation takes I don't know, 1/10 of the second or so, or something like that. And for us, it was like 2 or 3 seconds for very small application. But hopefully, Scala compiler will get faster and faster. At least we hear it for last few years. But it's really getting faster, although it's still slow, right? There are also not too many best practices, blueprints, like for example, when you have Spring, you know what to do. But here, all this stuff and community is pretty young, so not everything is fixed. But it's also the same for the JavaScript frameworks. In fact, there are no, I don't know, for me it's just a mayhem of different styles, frameworks, and so on. But of course, the biggest problem is the buy-in of the developers. Because if you take normal JavaScript developer and you show to him the Scala code, he'll run away. So in my humble opinion, Scala.js is not the way to force kind of hardcore web developers to develop in JVM. It's a way for us, JVM developers, to be able to write some front-end code without resorting to Babel, Grunt, and Gulp and stuff like that. Right. But Scala.js is pretty mature at this moment. It's not widely used in production, although in my company we've used it to be able to create some kind of isomorphic Scala that runs both in browser and in the backend. But I think it's mature enough to try it. Maybe in not so crucial project, but still. And there are some links if somebody is interested. Probably the slides will be somewhere, so don't bother to write it. Okay, so thanks. If you have any questions, then don't hesitate.
Have you used something like Elm?
I mean, yeah, I've seen Elm, and it looks pretty interesting. But you know, Elm is it's a really great idea, but you know, there's still a problem that it runs just in the browser, right? Isn't it?
Yeah, I mean, well.
Or you just ask about comparisons?
No, I'm just trying to do that. I think
Mm-hmm.
I'm having more and more trouble with writing the Scala for things like that. I think the code is hideous when you look at it. I mean, there's so much boilerplate in there. You want to do UI, front-end, JavaScript, I think they're much more easier things. And they're not code at heart.
Mm-hmm.
Things like time traveling debugger, where if you go like a game, you can basically literally just go back in time.
Yeah. But this is also possible with.
I think this is really innovation at the JavaScript level, but Scala.js, I think it's.
Yeah, but also, you know, this time traveling is not. I think it's not such distinct feature of Elm. In a way, because it's more like.
To know if you have a problem, to be able to go back into all the state.
Yeah. But it's a matter of how do you deal with the state, right? And the thing that I didn't show you because.
Instead of you having to take care of it.
Because yeah. But as I said, there are some libraries also in Scala.js that handle state just like that, right? Because I didn't have time to show it to you now, but I mean it's not unique a feature of Elm as a language, but it's just more a way of handling state, right? For example, when you have, did you hear about closure script OM and OM next, right? So it's doing more or less the same, right? So it's a less matter of language, but how do you deal with the state, right? If you have this immutable state that's kind of central in your application, then you can do such thing as you said.
Yeah.
I mean, this time travel. So in Scala.js, it's also possible, right?
Yeah, but you have to do it yourself.
You just have to use the library. Okay.
Yeah.
It's not idiomatic indeed, right? Yeah. This is true. I mean, yeah, I agree and I understand with what you're saying, right? That it's that the languages are. There are some languages that are kind of more idiomatic and fit to browser development.
I mean, I personally, I started writing Scala 7 years ago, and in the end, I decided that I thought that the way I program Scala is to write as purely functional as I can. But you end up hitting the limits of the language, and then you start wondering well, if I really want to do things like purely functional or like immutable, then I think there are more happier homes for it. But then again, it all depends on expertise.
You mean writing in Haskell and stuff like that?
Yeah,
Yeah. I mean, Scala is kind of
that's how my trip went. So
Scala is kind of rotten compromise, right?
yeah.
So if you can use purely functional languages, then yeah, it's much worse, right? But sometimes for various reasons you have to, or whatever, use JVM, right? And then, of course, you won't be that happy. You won't write such pure functional stuff. You won't have lazy evaluation and so on, right? But on the other hand, for me, it's more a matter of the thing that you don't have to talk to the client that he has to install some stuff on the server because he'll get the web archive, right? As he's used to. This is, in my opinion, this is the reason why we use Scala, and to large extent. So I understand that, and I kind of agree with what you're saying, but in reality, sometimes we have to to do compromises, right?